What is the relationship among special quadrilaterals? This video is for task 6.4. So make sure this goes at the top of your paper along with the title of 6.4, and make sure that the video title goes in the left-hand column. Here's an example of what your notes should look like to take notes from this video. Okay, throughout this video, I'm going to explain the special relationship between quadrilaterals, and I'm also going to give you two examples on how you can use these relationships to help you solve some pieces to a puzzle of a quadrilateral. So here we have a slide where it explains what quadrilaterals are. Quadrilaterals are any polygon with 4 sides and 4 angles. So as long as you have 4 sides and 4 angles, you'll get quadrilateral. And notice that in the word quadrilateral, you have the word quad, and quad means 4. Think of like a type of bike that has 4 wheels. A quad will have 4 sides and 4 angles for the quadrilateral. So let's take a look at some examples. We have 5 here. The first one is a square, and we're going to have to do some extra notations, and you'll see what I mean. A square has all sides are the same length and has 4 right angles. So it notated the 4 right angles, but let me notate the same length for all 4 sides. Remember, one little tick mark means that all 4 sides are congruent for a square. A rhombus has 2 pairs of parallel sides, and all sides are the same length. And it also has 2 acute angles and 2 obtuse angles. So we can't notate the acute or obtuse angles, but we can notate that all sides are equal. And also, we have 2 pairs of parallel sides. So let me show you how we notate parallel. We actually use a little arrow. So that shows that both those sides are parallel. And then let's do double arrows here, which shows that the top and bottom are parallel as well. Just a reminder, you should have paused the slide and make sure you wrote down all the pictures and all the information. Next, we have the rectangle. Opposite sides are parallel. Just like the rhombus, also opposite sides are parallel. And they have the same length. And there's also 4 right triangles. So this side is the same length as this side, and they're also parallel to each other. The top and the bottom are also congruent to each other, but not to the side lengths. And they also have parallels. They're also parallel to each other, so we could do double arrows. Okay, a parallelogram. It has 2 pairs of opposite parallel sides. So let's notate the parallel. Double arrows. That shows that both sides are they have 2 pairs of parallel sides. So this side is parallel to this side. This side is parallel to this side. And also has 2 acute angles and 2 obtuse angles, just like the rhombus. So notice there's some similarities there. That's what we call a relationship. And the trapezoid has only 1 pair of parallel sides, and it's the top and the bottom. Those are parallel to each other. And that's all the trapezoid has. So notice that we start to see some things that they have in common. On our next slide, you'll see what I mean, and it will really explain the relationship among the quadrilaterals. In your textbook, there is this type of diagram, but it's with branches, like lines, and then it explains the relationship between the quadrilaterals. But I found this Venn diagram, and I thought it'd be really helpful. So remember, everything in here is a quadrilateral. That's the big picture. And then we'll start getting into the smaller pictures. You can have a quadrilateral that has no sides parallel. It can look something like this as an example. So there's no name for this type of figure except a quadrilateral. You can also have a quadrilateral that's a trapezoid. Remember, a trapezoid has 1 pair of parallel sides. And here's an example here. Now, you can also have quadrilaterals or also parallelograms. And parallelograms have at least 2 pairs of parallel lines. So here we have a rectangle that also has 2 pairs of parallel lines, which is called a parallelogram. We have a square that is also a rectangle, and it's a rhombus. It has 2 pairs of parallel lines, has all right angles and 4 congruent sides. And here's a rhombus. It has 4 congruent sides, but it also has 2 pairs of parallel lines. So how you read this is you start on the inside and then you work your way on the outside. So let me explain how they're connected. A rectangle and a square have a relationship. So a square is also a rectangle. A square is also a rhombus. They have a relationship. They have something in common. A rhombus has four congruent sides, so does a square. A rectangle has all right angles, so does a square. But notice a rectangle and a rhombus do not have things in common, except for the parallel lines. And that's why they're underneath the parallelogram. And so the parallelogram goes here and there. Next, a trapezoid does not fit in this category whatsoever, so that's why it's on the outside of the parallelograms, but it's still a quadrilateral. So you guys need to know the relationship between these, and you're going to be writing down this information for one of your Ready, Set, Go assignments. Remember, the relationship between quadrilaterals is what do they have in common. So here's an example of how you can apply the information that we just discussed. And it's mostly filled out, so go ahead and pause the video, write everything down, and then I'm going to go ahead and highlight some information and discuss it with you. Alright, let's go ahead and take a look. We were given this graph right here, and it has point A, B, C, and D. Those are all coordinate points. So one thing you probably want to do is label what those coordinate points are. After you've done that, then you can tell what type of quadrilateral it is by seeing if the sides are parallel. Remember, parallel slope is the same. Let me go ahead and write that down, and you should write that down too. Parallel slope is the same. This is why we've been talking about parallel and perpendicular slope in class. It's because now we're going to apply it with quadrilaterals as well. So if I can prove that two sides have parallel sides, two opposite sides are parallel, that means that they have the same slope, then I can prove that this shape is a parallelogram. So here, we have to first remember that the slope formula. So here's a formula. You can also remember it's a difference of y all over the difference of x. Okay, that's also the same thing. Difference means subtract the y values, subtract the x values. So you don't really have to memorize this formula. And just a side note, you can also use, oh, sorry, you know what? Not the side note. I'll explain that at the end. So let's go ahead and calculate the slope. If we look at line AB, which is right here, we need to calculate the slope. Now you can either use the slope formula by using the points like they did, or we could just do rise and run. So if we go up 3 and over 1, our slope is going to be 3. For the slope of BC, which is right here, we can also do rise and run. So up 2 over 3. So there's our slope there. Then we look at slope of DC, which is here. Do rise and run as well. So go down 3 and over 1, negative 1, so we got positive 3. Notice that AB and DC have the same slope. Therefore, these two lines are parallel. And I should do that with a different color. Let's do it with red. There you go. And then let's look at the slope of AD. AD is right here. And we can also do rise and run. So we can go down negative 2 and over negative 3. And we would get positive 2/3. Notice that these two slopes are the same. Therefore, these two sides are parallel. So let's notate that. Now, there was two ways to calculate the slope. Rise and run, which is what we just did because we've been practicing that a lot. But you can also calculate it using the formula, which is what they did in this example. So since parallel lines have equal slope, then AB is parallel to DC and BC is parallel to AD. Therefore, ABC is a parallelogram because it has two sets of parallel sides. Now, if you can figure out the distance of the sides, the length of the sides, then you can figure out if it's a square, a rectangle, a square, or a rhombus. And you can use Pythagorean theorem. If I know that this is 3 units and this is 1 unit for this triangle right here, I can use Pythagorean theorem and find the distance or the length of DC. You can also use the distance formula, which we're going to discuss in class. It's very similar to Pythagorean theorem. Okay, let's go ahead and take a look at one more example. For this example, we want to find the values of the variables to prove the quadrilateral is a parallelogram. Remember, a parallelogram has two pairs of opposite parallel sides, and it has 2 acute angles and 2 obtuse angles. So I just want to go ahead and make sure that since these sides are parallel, they should be also, excuse me, let me put that back. Since these sides are parallel, they are also congruent. Notice that they has the markings for congruent sides. So let's go ahead and take a look at the red sides. We're going to set these equal to each other since they are congruent. So we get 3b plus 2 equals 4b minus 2. Subtract 3b to both sides, so you get 2 equals b minus 2, and then add 2, so b equals 4. So now that I have my b, I can plug it in here and find the length. Plug it in right there for that b and find the length. So 3 times 4 is 12, plus 2 is 14. And it should also be the same down here for the second side. 4 times 4 is 16, minus 2 is 14. So that was correct. We got two sides equal. And now let's go ahead and take a look at the other two sides. Now notice if I take 5a plus 4 and I set that equal to 3b plus 8, I would not be able to solve for an unknown variable because I have two unknown variables. I have an a and a b. But I already know what b is, so I can plug b for 4 right there, and then I can go in and solve this equation for a and find out what a is. So we have 5a plus 4 equals 3 times 4 plus 8. Notice I'm plugging in the 4 for b. So 5a plus 4 is going to equal, let's see, 3 times 4 is 12, plus 8 is going to be 20. Minus 4, so I get 5a equals 16. And divide both sides by 5, and a is going to equal 3.2, and I just used a calculator to get that. It'll also be a fraction. So now that I have that a, I can then take a and plug it in for this side length and find out what that side length is, and take this 4 and plug it in for b. And so now if I did plug that in, I would get this side length to be 20. And if I plug in 4 here, and then I for the b in this one, and then I multiply and add 8, I would also get 20. So notice now this side is congruent to this side, and 14 is congruent to this side for 14. Okay, make sure you bring your questions to class. If you had difficulty with the video, replay it. If you missed anything, go ahead and replay it as well. Also, make sure that you add some extra notes in, explaining what maybe I explained. A good idea would be to write down the steps, especially for this example. It would be good to write down some steps. Okay, see you in class.